Hello everyone, in this video we are going to discuss a question on battening system. Okay, next question is on batten system, design of batten system. So for this question also we make use of the information discussed in the last question, hence I'm not going to repeat all those informations of question. Okay, that is the reason I said keep that question with you when we are discussing batten system and design system, batten system and lane system design. Okay, so batten system, the same information we are going to make use of, the same question we are going to use, but those built up columns we are going to made or built by making use of batten system, not lacing. That is not the difference. Now for batten system, the effective length is increased by 10%, that is 1.1 into KL. 1.1 into KL means 1.1 into 10,000, right? Which comes out to 11 ml. So this is effective length. Okay, this is effective length. By making use of this effect length, we calculate the slenderness ratio. Okay, we calculate the slenderness ratio. That is 11,100 by 118. Okay, 000 by 118. Then it comes out to be 93.22. This is the slenderness ratio for that battened built-up column. For laced built-up column, slenderness ratio is around 88.92. It means slenderness ratio is more in comparison to the previous case. In this case, slenderness ratio is more. From this, it is very clear that load carrying capacity of batten column is less in comparison to the lacing column. Is that okay, everyone? From this slenderness ratio, it is very clear. So slenderness ratio in previous case is how much? 88.98. In this case is 93.22. As more slenderness ratio is present in this case, therefore less load carrying capacity. Clear, everyone? Come back to our discussion. As standard values already we have taken, or we know. For 90, for slenderness ratio 90, FCD is how much? 121. And for 100, how much it is? 107. Now we want for 93.22, right? This FCD we required. Okay, this FCD we required. So this FCD, by these known values, we can find by linear interpolation. Directly I write that formula FCD is equal to 93.22 minus 100 upon 90 minus 100. Okay, 93.22 minus 100 by 90 minus 100 into 121 minus 107 plus 107. So upon simplifying, we'll get this value as 116.492 Newton per mm square. Okay, this is the value. Okay, this is the value of FCD we will get. Now from this value of FCD, we can calculate design compressive strength. Okay, design compressive strength of that batten column. So PD is equal to AE into FCD. We know that AE is nothing but gross area. Okay, gross area of that batten column. So for making the batten built up column, we are using two channels back to back. Hence area is nothing but twice the area of individual channel into FCD is how much? 116.492. Upon simplifying, we will get this as 1078. Okay, 1078.8 kilonewton, which is greater than 1000 kilonewton. Of course, it is safe. Okay, it is safe. This is the first part. Now, second part is spacing. The same channels we are making use. Okay, the same channels we are making use. Hence, the spacing in this case is also same as that of previous case. So, spacing of channels. Okay, spacing of channels. So, spacing is same. Again, I am not going to do all the calculations what we have done in previous question. Is that okay? But the diagram I am going to show again. So, this is one channel. Clear? And this is another channel. Now these two channels are connected by making use of batten system. Is that okay? So basically condition I will mention, but the calculation again I am not going to repeat. So condition for spacing of the channel is Ixx of whole column should be less than or equal to Iyy of whole column, right? The calculations are one and the same. That is the reason I'm not going to repeat it. But the diagram is very much required. That is the reason I'm going to show the diagram again. Okay, these were the axes. This is xx and this is yy, right? Here where the CG of the whole component lies. Sorry, whole built-up column lies. And here where CG of the individual channel lies. So this distance is how much? Cy. And the same way, this distance is also how much? Cy. And this distance is how much? X, right? Now there exists one parameter here, that is alpha. We represent that parameter with alpha. So that alpha here, let me write. Here I will write. Now alpha is equal to how much? X plus 2cy. Is that okay? There exists one more parameter. What is that parameter? So this is the gauge distance, G. In the question it was mentioned as the 50. This is also gauge distance, G. And this is X as usual. Okay, this is X. Now one more parameter is going to exist, that is S, which is nothing but X plus 2G. So these two are very important parameters in the design of batten system. In the design of batten system, these two are the very important parameters. That is the reason those parameters are shown in the cross-sectional view. Is that okay? So this is what the design of built-up column. Now let us see the design of battens. Okay, design of battens. So design of batten means finding out the spacing between the two battens and finding out the width, thickness and length of that batten and forces coming onto that batten and movement coming onto the batten. Okay, everyone. So that is what the design of batten means. First, let us start the design of batten with finding out the spacing. So these two are the very important things. So here, let me write here. Alpha is equal to X plus 2cy and S is equal to X plus 2g. Okay. Now the longitudinal diagram is also required. These are the, okay, this is the flange. This is one flange of a channel and this is the another flange of a channel. Here our battens were provided. So minimum number of 3 bays. Okay, when we built a column by making use of batten, then minimum of 3 bays are required, which is what already discussed, right? Now this is the spacing. Here, this is the spacing. And this we can consider it as it is a end batten. So these two are the end battens and these are the intermediate battens. So this is considered as a effective depth of end batten. And this is considered as a effective depth of intermediate batten. So D enter, right? And the overall depth we will get, okay, overall depth is the D. So overall depth we will get D enter plus twice the end distance. Yes or no? Twice the end distance. In the same way, here also we will get the overall depth or width, you can say, by adding effective depth of end batten plus twice the end distance. Is that okay? So this is the spacing. So these are the required dimensions. And this is the bay 1. And this is bay 2. And this is bay 3. So minimum number of 3 bays are required. Means four battens are required. If you want to build a column by using batten system, then 4 battens are required. So in the diagram it is very clear. Now first let us start with finding out the spacing. So for the spacing, the same provision is present. Same provision as that of lacing is present. That is C upon R minimum of a component should not be greater than 50 or 0.7 into KLR upon whole column. Is that okay? And coming to the KL upon R of whole column is 93.22. Already we have calculated. Okay, already we have calculated in the beginning of this question. So 0.7 into 93.22, it comes out to be something around 65.254. Now out of these two, the minimum we need to take. So this is 65.24 and this is 50. So we go with 50. Okay, we go with 50. And the spacing, C, unknown to us. That is what we need to calculate. C upon R minimum of a component we need to take. That means 26, not 118. So 118 is the minimum for a built-up column. But for a component or individual, it is 26. Should be less than 50, right? Okay, it should be less than 50. It means should not be greater than, means it should always less than 50. Means out of these two, whichever is minimum, that we have to take. So 50 we have taken. From this, C should be less than 50 into 26. It comes out to be some 13, around 1300. Okay, it comes out to be around 1300 mm. So the spacing between the two batons should be less than 1300. So provide C is equal to 1250, 1250 mm. So this is the spacing, first provision. Okay, first unknown thing. Okay, first unknown thing, that is spacing between the baton. We have calculated that. That is 1250 mm. Is that okay? Now later we go for calculating or finding out this D end, means effective depth of end baton and effective depth of intermediate baton, means width. Okay, effective width also we can say, but in the code it was mentioned as the depth. That is the reason we are using the same terminology. And that too, for those effective depths for end and intermediate baton, we are having the provisions mentioned in the code. Now what are those provisions? Already we have discussed in our conceptual part, but as here we are solving the question, we require, okay, we need to recollect those provisions. So first we take it up. Okay, so second one, see that second one, first part. So D end means effective depth of end baton should not be less than alpha or 2BF. Is that okay? So what is alpha here? It is alpha. So let me calculate alpha here. X is how much? X is, so alpha is equal to X plus 2CY. So alpha is equal to X. So X is how much? 183. So X is 183 plus 2 into 20. CY is nothing but 23.5. This was also given. So upon simplifying, 183 plus 2 into 23.25, we'll get this as we'll get alpha value as 230. Okay, and 2BF. So BF is 90. So 2 into 90, how much it is? 180. Is that clear? So out of these two, okay, out of these two, which is minimum? Sorry, which is greater? 230 is greater, right? So here we need to take alpha. Okay, here we need to take alpha. Okay, now the D end should be less than 230. Okay, should not be less than 230. Sorry, should not be less than 230. Means it should be greater than 230 mm. Therefore, provide D end as 240. As here, effective depth of end baton should be greater than 230. So out of these two, whichever is more, so let me write here, whichever is more, that should be taken here. And the D end should not be less than that greater value. It means it should be greater. So it should not be less. Sorry. Out of these two values, that is alpha and 2BF, we need to take more value. Now, this effective depth of end baton should not be less than that greater value. It means it should be greater than 230. It means that is the reason let us provide 240. We can provide any value greater than 230. Here I have taken 240. That is our choice. Okay. Now coming to the overall depth. Overall depth is nothing but D end plus twice the edge distance. Okay, twice the edge distance. For edge distance, again we are having the provision. What is the provision for edge distance? Provision for edge distance, here let me write 1.5 into DH, right? So this is the provision for edge distance. So 1.5 into DH is nothing but 1.5 into dia of the bolt here is 16. So for 16 mm, the dia of the bolt hole should be increased by 2 mm. That is 16 plus 2. So 1.5 into 18. So this comes out to be 1.5 into 18. So this comes out to be 27 mm. This comes out to be 27 mm. This is the edge distance. So these are the values of alpha and 2 beta. Okay, these are the values of alpha and 2 beta. Now D end is 240 plus twice the 27 means 54. So it comes out to be 294 mm. So this much of overall depth of the end batten is required. Now let us see for intermediate batten. So D inter should not be less than 3/4 of alpha or 2 BF, whichever is more. So already we know 2 BF is 180. Now 3/4 of 230. Okay, 3/4 of 230 is nothing but, so here let me write 3/4 of 230. Okay, 3/4 of 230 comes out to be 172.5 and 180. Out of these two, whichever is more, 180 is more, right? 180 is the more. Now this D inter should be greater than 180. Implies provide D inter as 190. Okay, D inter as 190. Now overall depth is nothing but D inter plus twice the end distance. Okay, twice the end distance. So the 190 plus 54, which comes out to be 244 mm. So this is the overall width. Okay, the 244 is the overall width for intermediate batten, and 294 is the overall width for end batten. Is that okay? So this is what the width for the intermediate and end battens. Now let us find, or let us calculate the required thickness and length also. Okay, required thickness and length also. Okay, here in the diagram there is a small correction. It means here the batten should be provided up to the end. Here up to here the batten should be provided. Okay, small correction in the diagram. Then our calculations will be simple, or else it will be somewhat lengthy. Now coming to the length, okay, before going out to calculate the thickness, we need to determine the length. So what is the length here? See here, length of the batten. This is the spacing of the channels X, right? And this is the width, BF. This is the width of the flange of a channel, BF. Now length. Okay, length of the batten is nothing but X plus 2BF, right? So length of the batten is nothing but, here let me write, length of the batten is equal to, let me write with KL. So length of the batten. Okay, length of the batten is equal to X is 183 plus 2 into 90. Is that okay? So 2 into 90 is nothing but 180. 180 plus 183, it is 363 mm. Now length of the batten is 363 mm. So length is same for intermediate and end batten. Whereas depth will vary. Means effective depth and overall depth may vary, but length is same. And even thickness is also same. Only the difference is width, or you can say effective depth and overall depth, or effective width or overall width, everyone. Is that okay? Now let us calculate the thickness also. Okay, let us calculate the thickness also. T. Thickness of the batten is equal to S upon 50. Is that okay? Now what is the S here? S is equal to X plus 2G. Okay, X is equal to S plus 2G. X is 183 plus G is nothing but 100. Okay, 2G is 100 by 50. So 183 plus 100 is 283 upon 50. Then approximately we are going to get it as this value. Approximately we will get this value as 5.66 mm. Now what were the dimensions? Okay, what were the dimensions required? Width for end batten is 294 and thickness, let us take it as 6 mm. Okay, thickness is 6 mm and length is 363. For intermediate, width is 244 and the thickness is same and length is also same. Now let me write the values by rubbing this. Let me write the values of intermediate batten, means dimensions of intermediate and end batten. End batten. So for end batten, required 294 mm into length is how much? 363. First let us write the length. Okay, 363 mm into 294 mm into 6 mm. Hence provide 363. Hence provide 363 into 300 into 6. Okay, so hence provide these dimensions as a end pattern. And coming to the intermediate pattern, so required are 363 into 244 into 6. Now provide 363 into 250 into 6 mm. Is that clear? So these are the provided dimensions for end and intermediate pattern. So with this, the dimensions determination is completed. Now let us see the force onto the batten system and longitudinal shear force in individual batten and moment in batten. Okay. So for that, let me rub this. Now these details are no more required. Okay, like in the lacing system, batten system is also designed for transverse shear of 2.5% of axial load. So we know that axial load is how much? 1000 kilonewton. Okay, now force, transverse shear force is 2.5 into 1000 upon 100, right? It comes out to be 25 kilonewton. So this much, for this much of force, we need to design batten system, total batten system. Now let us see longitudinal shear force. Okay, longitudinal shear force in individual batten. So the formula here is Vc by Ns. Clear? Vc by Ns. Now V is how much? 25 kilonewton. And spacing is, just now we have calculated how much the spacing. Spacing we have calculated as 1 2, or we have provided spacing as 1250. And number of planes of batten here are 2 into S. S is nothing but how much? 283. Okay, 283. All the values are known to us. Upon simplifying, we'll get it as 55.21 kilonewton. Now let us see moment. Moment is equal to Vc by 2n, right? V is how much? 25. And C is how much? 1250. And that too, here we require in kilonewton meter. Therefore, it is in mm. Convert into meter by 2 into 2. Clear, everyone? Upon simplifying, we'll get this value as 7.812 kilonewton. These are the force and moment in the batten system. So with this, we have completed even the design of batten also. Okay, with this, we have completed design of batten also. Once I repeat, this much of lengthy questions are not at all expected in the final gate examination. But any part, what we have discussed so far in this question, may be expected for 1 mark or 2 mark. Is that okay? Because of the reason only I have explained the total procedure of the batten system. Okay, please take it on.